Okay?
Yes, sir.
We have got a frame which has got a horizontal member and a vertical member. The frame is subjected to these two loads. One is 5 kip and another one is 3 kip. Okay. Okay, so now this is 15 feet long. So 15 feet would be approximately how much?
So very much long.
Approximately the height of this room. But it would be slightly more than the height of this room. Yeah, it will be more than the height of this room. This room would be 12, 13, but say approximately. So the height of the room is
If we
approximately.
remove the ceiling, then height of the room.
Yeah, so that is 15 feet, okay? And this one is 11 feet, which is almost the same order of magnitude. So imagine like this is almost this length, and this length is approximately the same length as the height of this room, okay? Then we have a 5 kip, which is 5,000 pounds. So how much is 5,000 pounds approximately?
So one car.
Sir, 5
cars.
Okay.
5 cars.
No.
No.
It's not kg. We said that one car would be approximately say 1 ton or 1.1 ton, okay, or 1100 kg or something like that. So, so how much is this?
2 cars, almost 2 cars.
Yeah, this load is equivalent to almost 2 cars. Almost 2 cars.
Yes, sir.
Okay, so we are talking about not very small cars. We are talking about the modern cars. Okay, and this one,
1.5 cars.
yeah, but I mean like this is approximately the weight which is applied on this structure. Okay, so you have. So this is 5 kg. So we are saying that this is approximately 2 cars, and this will be a 1 ordinary car and 1 small car.
Yes.
Okay, that would be the type of load which is applied. Now, the first step, as I told you, the first step is determinacy. Stability. So, okay, we have got 3 reactions. So, R is equal to 3 times N. Yeah. R is equal to 3 and N is 1. Okay, so 3 is equal to 3. This is one member. I told you that N will only become bigger than 1 if you have any of releases in between your members. Okay, so that can be a shear release, axial force release, or the moment release. Okay, so then that makes it 2, but in this case it's 1 G.
So at C point there is 6 points.
Yeah, but that is internal. We are talking about the boundaries. These are the boundaries. Okay.
Okay, sir.
When I drew that structure, where were the boundaries of that structure?
Yes, sir.
Where were the boundaries? Remember, a few minutes back I drew a structure which had frames. Where were the boundaries of that structure?
At the bottom.
Where is the end? What do you mean the end?
A point is equal.
Where were the boundaries of that structure?
The at the bottom.
No, the boundaries were on the ground.
Yes, sir.
Ground is actually your support,
Yes, sir.
where ultimately your load is going. In this case, you have this member which is connected to some other member. It might be a wall or it might be some other structure. So this one is ground and this one might be a wall or something else. Okay, so imagine I have a, so we have this structure. This structure, for example, is joined to the wall, and we have got over here. So we have got two boundaries. One is this here, and another one is here. We have got two boundaries. Okay, so that's what we are saying. Now, so this is determinant. And it is also stable because R is equal to 3n. Okay? Or so it's stable because R is equal to 3n. Okay? Now that is our stability. Now after that, let us find out, we have reactions. Reactions. What do we have? So moment at B must be equal to 0, and that is AY times 15 minus 3 times 5 minus 5 times 15 must be equal to 0, and AY comes out to be what is AY? Give me AY. Then we, sorry?
I think 4 minus no 96 minus 6 minus
AY is 6. Okay. Fx is yes, you can apply summation of y or summation of x moment, whichever you want. So dy is equal to 1. Okay, so now our
Sir,
AY
3 into 11 plus 11.
Sir, 3 into 11 नहीं होगा, 5 into 11 नहीं होगा, नहीं.
So 3 into 11 को और
5 into 6 होगा.
3 into 6
Why?
होगा, 5 into 11 होगा.
5 k is 6.
सन ऊपर 3 into 11 होगा.
अच्छा dx की बात करते हैं
हाँ, 3 लिखा है, ये 5 है.
what do you mean 5 into 11? We are going to take a moment about a. dx times dx times 11 is 3 to 11 and
11 16 आएगा.
dy.
Multiple distance देखो. सही है सर, सही है.
तुम्हारी कितनी बात dx is
माइनस नहीं करना
dx3 किया है.
Okay, now we do structure analysis. Okay, by structure analysis I mean we find the body forces and then the internal forces and shear force and bending moment diagram. So we have got AC member. AC member has got force 6 kip.
Yes, sir.
It has got 3 kip over here applied. This joint, every point on the structure must be in equilibrium. Okay, so that means that every point must satisfy equilibrium equation. Okay, so for point C, we must have summation of force in the y direction must be 0. So this is 6k. Summation of force in the x direction must be 0. 5k. So that is we will do that. We will handle 5k in the on the other members. Okay, you will see what we do. But you start from here, from the end, and you find out all the unknowns at the joint. Then you adjust that joint. So you will see what we do. Okay, you will see how we adjust our 5k. So we have got 6 kip over here. Yes, we have got 3 kip over here and moment. So we have 3 times 5, which is 15, and that is in this direction, and this one will be 15 kip in this direction. Okay? My point is, at point C must satisfy all your equilibrium conditions. We have got 3 conditions. Why? Because we have got a plane structure. In plane structure we discussed we have got 3 equilibrium conditions. forces in x, forces in y, and summation of moment. All of them must be equal to 0. So we have, so force in the y direction must be 0. So you have 6 kip applied in the opposite direction to the 6 kip, which is at the at point A. Okay. We have forces in the x direction must be equal to 0. So the 3 kip is applied in the opposite direction to the 3 kip load applied at B. Okay, and now the moment must be equal to 0. All the moments must be equal to 0. So you have to find out the moment which is applied on this at this point C. Okay, what moment is applied at point C? That moment is 3 kip times 5. Okay, this is not contributing to the 6 kip is not contributing to the moment. Why? Because the lever arm is 0.
Yes.
Okay, so it is only 3 times. So that is clockwise. That is counterclockwise. 3 times 5 load, that is applied counterclockwise. So you have to apply a clockwise moment to counteract that.
Yes, sir.
Okay, so therefore I have applied 15 foot kip clockwise. So that's this is the free body diagram of AC. Okay, now let's draw free body diagram of CD. Okay, now is this okay?
Yes, sir.
Is this okay? Now at point C, at every joint, you have to see what are the external forces applied, and those, so you must make sure that overall you have that external force applied onto the joint. So according to this equation, we have made this joint, we have 6 kip applied over here. Okay, now but externally there is 5 kip applied on this joint. So we must have, so this joint and this joint, the summation of this must give us 5 kip. If this 5 kip was not applied, I would have put a 6 kip in opposite direction, because in order to make it in equilibrium. Okay, but currently we have 5 kip applied on this joint. So what should I do? I've got 6 kip in this direction. I must apply 1 kip in the opposite direction in order to get the net force of 5 kip. So I apply 1 kip in this direction. Okay?
Yes, sir.
Now, there is no external moment applied. So therefore, I can apply opposite moment to this one to satisfy my equilibrium. At every joint also, the equilibrium must be satisfied. The equilibrium is satisfied. By doing this, we satisfy the equilibrium for this member. Now, at C, we are satisfying the equilibrium for the joint. So we have
15K counterclockwise.
Yeah, so we will have 15K counterclockwise. Okay? Is that okay? 15K and 3K in the opposite direction, which is summation of fx must be equal to 0. Is this okay?
Yes, sir.
Now, at point D, what should we have? We should have summation of fx for the member. We must have summation of fx must be equal to 0. So 3 kip and 3 kip in this direction. Yeah, and that agree with
Yes, sir.
are reactions. Summation of Fy must be equal to 0. One kip in this direction, one kip in this direction. And that agrees with this one.
Yes, sir.
Now let's check whether the moment is coming down to 0, because what is the moment? 0. So look, 1 times 15 and 15. 1 times 15 clockwise, and this is
Yes.
anti-clockwise, so the moment is
0.
okay, the moment is 0.
Sir, can you repeat this moment?
Moment 1 times 15, that is clockwise, and we have another moment which is minus 15 anti-clockwise. So at this point the moment is 0.
Yes.
Okay? So these are the free body diagrams. Any questions so far? Yes. ये 3 clips, this 3 clips we have applied. This is the 3 clips. This 3 clip load I have applied in opposite direction. Why? Because the equilibrium must be satisfied in next direction. Now once I applied in this direction at point B, this must be applied in the opposite direction, because again the equilibrium has to be satisfied. So therefore 3 clips I have applied in the opposite direction. Okay?
That joint is fixed.
This joint is fixed. Yes.
It has to go.
No, this is, it is taking moment, it has got moment, 15-foot kick. It has got moment, it's not 0 over here, but that, the net moment is 0. Why? Because it is in equilibrium. If this is not 0, then this joint will be rotating at a frequency. So you don't want that. Is this? It has to be 0. Okay, so this is a fixed connection, and that's why you have moments appearing over here. If this was a pin connection, these moments wouldn't have come. Similar to this one. Look, automatically it has become 0. Okay, now let's quickly draw shear force bending moment diagram for this one. Shear force diagram. For shear force diagram, we will make a convention, and let that convention be that clockwise all those shear forces, or all those forces which are capable to produce shear force, shear in the structure, they are positive if they cause clockwise rotation. Okay, so shear force clockwise positive. Okay, that's for shear. Okay, and moment we will draw on the tension side. What do I mean moment drawn on the tension side? What I mean is, if I have this structure and this structure is bent like this, okay, so this is tension and that one, the top one, is compression. So I'll draw my moment over here. Okay, so for example, if I have for example, if I have a beam and I put a load on it, my bending moment diagram should look like this. Okay, why? Because tension is at the bottom. I am applying load like this, and this is my tension side. So I'll draw my bending moment on the tension side,
Okay.
not on the compression side. Okay, that's what my convention is. Okay, so I will write bending moment is on the tension side. So bending moment on tension side. So shear force, there is, for shear force it is important that the applied load is perpendicular or at some inclination with respect to the axis of the component. Okay, in other words, I have got this structural component AC, and the applied load is should be either perpendicular or have some inclination. Okay, not zero. The load which is 0, which is 6 kip, that is not causing any shear force, that is just causing compression. Okay, so for shear force that is important. So this is only the load which is causing shear force. So this one, so my shear force from A to B will be 0. Okay, this will be 0, and then look at this. I've got this thing and I've got this thing. So this is, what is this? What rotation is it causing? This one and this one. Counterclockwise. Counterclockwise. And I'm saying clockwise is positive. So I will write negative. This is my shear force diagram. Do you understand? This is 3K, this is 3K. This is causing counterclockwise. Okay? So I will call it negative. You can also have a convention having counterclockwise positive. Then you call it.
So we will follow you.
Okay, so make it okay. So then make it counterclockwise positive. Okay, so then what is this? This is positive. This then positive. If you want, we can make it counterclockwise is positive and yeah. So we'll revise our convention. Okay. Now this is our SFT and sorry.
सर इसकी हाइट का कैसे पता कि इतनी विड्थ मिल जाएगी?
No, because this is, look, this is 3. This is 3, isn't it? This comes like this, 3, and then this pull it back. Okay, so this go and then it's kicked back to the main axis. Okay, so that is 3. So this is 3. And okay, now how about the bending moment? The bending moment, which direction should I draw my bending moment in? So, no, but I mean, you have got load applied in this direction, so tension will be in this direction. So I will draw it in this direction, okay? Not on this side. Okay, I'll draw it on this side. Now, we have. So what should I do?
0 until 3 and then you will take
Yeah.
15.
3 to 5, 15.
वो क्या करते हैं?
Okay, that's my bending moment. Is this okay?
Yes, sir. Yes, sir.
Okay, now let's quickly finish it off. This one is now.
One किया आप.
The shear force again is how much? 1. And this is clockwise. So I should, we have counterclockwise is positive. So Is it okay?
Yes, sir.
Shear force and the bending moment. Okay, so the bending moment is
15, sir.
and
0 to 15.
15 to
yes, but
15 to
first
0.
of all, should I
15 to
draw
0.
it
Sir,
upward or downward?
Upward, sir.
Why?
The tension is
Because this is tension. Yeah, this is tension side, this is compression side.
Yes, sir.
So I have to draw it. This one, and then it comes down to
मोमेंट का दोनों मोमेंट
ये कैसे पता चले जाएगा कि ऊपर टेंशन है या नीचे टेंशन है?
हिसाब लगाओ ना यार। इस साइड में फोर्स है, उस साइड में टेंशन है, सर।
okay. Now, how would we know whether it's tension upward or downward? Is the tension upward or downward? How would we know
This
that?
direction में
Because see, I am applying. This is a moment, isn't it? I am applying moment in this direction. So, is the tension upward or downward?
Upward.
Upward. So that's why. Okay. SFD is you have one kip in this direction, one kip is this direction. These two are actually the candidates for shear force, isn't it? So this is causing clockwise direction. Clockwise. So we have called counterclockwise as positive. Okay? So because you guys are comfortable with counterclockwise being positive.
सर ये SFD के अंदर हम ये नीचे वाली लाइन से ऊपर गए हैं या ऊपर से नीचे आए हैं?
ये तो this is the same. What do you mean? How do you want to do that? It's up to you. You just have to make it either positive or negative. I mean, like, what difference does it make? You tell me. If I draw it like this, negative, or if I draw it like this, negative. What's the difference between these two? So, okay.
Sir, there is upper number. The movement is applied in that direction. So tension is from the top.
Sorry, say it again. This one.
The movement is in this direction.
Yes. Look, we start from here. We don't start from the top. We start from here. And then you go to the top. Okay? Yes, attend. Can someone log in, please? Please.